Hello, my name is Nurul Nadira binti Muhammad Sanusi and my student ID is 2022838056.
My name is Raina binti Zakaria and my metric number is 2022482156.
Hi, Assalamualaikum. My name is Nurul Atira binti Muhammad Zakri and my matrix number is 2022628628.
I will explain to you about related rates. Related rates is the problems involve two or more variables that change at the same time, possibly at different rates. Related rates help us determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity. When do we apply related rates? We can apply it when solving practical problems that involves geometry formula and function. Usually, these problems use chain rule method and implicit method. Hi, I'm Nurul Nadira will explain to you about an application of differentiation. First and foremost, we need to know what is differentiation. Differentiation is a method of finding the derivative of a function. Secondly, when do we apply differentiation? We can apply it when finding the instantaneous rate of change in function based on one of its variables. For example, rate of change of gradient is equal to delta y over delta x. In addition, there are other applications of differentiation. For instance, analysis of function involving increasing and decreasing, applied minima and maxima problems, linear approximation, and row theorem, also mean value theorem. Let us take a look of this problem statement. Consider a cone as shown below. Water flow out from a cone through a hole located at the bottom tip at the rate of 5 cm³ per second. Find the rate of change of the height of the water when the volume of the water in the cone is 3000 pi cm³.
There are two objectives of this question. First is to determine the rate of change of the height of the water and to apply change rule formula in differentiation. So, in this case, we need to use the change rule formula, which is dH per dt equals to dV per dt multiplied with dH per dV. The given information in the question is dV per dt equals to 5 cm³ per second, and we need to find dH per dt and dH per dV. So, in order to find dH per dt, we need to find dH per dV first. For the first step, we need to find the radius. So, to find the radius, we must use the rule of sin constant, which is known as Sauve-Courtois. So, it will be R per H equals to tangent 30. So, it will be R equal to H tangent 30. Make it as equation A. To find the height, we must know the volume of the cylindrical cone. The volume of the cylindrical cone is 1 over 3 pi r squared h. So, form an equation and it will be 1 over 3 pi r squared h equals to 3000 pi. So, you will get the final answer r squared h equal to 9000. And make it as equation B. And then, substitute equation A into the equation B to get the height. So, the final answer we will get the height is h equals to 30. For the third step, we need to find the volume V and dH per dV. Once again, use the volume of the cylindrical cone, which is V equal to 1 over 3 pi r squared h. and then substitute the radius and the height into the equation. So, the volume, we will get 1/9 pi h cube. Then, differentiate the volume of the cylindrical cone that we get just now and insert the height of the cylindrical cone, and we will get dV per dH equals to 300 pi, and dH per dV will become 1/300 pi. So now we already know dH per dV is equal to 1/300 pi and dV per dt equal to 5 cm cube per second. So use the chain rule formula to get dH per dt. So it will be 5 multiplied with 1/300 pi, and we will get the answer 1/6t pi.
End of this, objective is to determine the rate of change of water head and using the chain rule formula in the differentiation that has been achieved. As we can see, from the solution dV per dH can be found when the volume of cone is known. Last but not least, we need to invert dV per dH to get the answer for dH per dt equation using the chain rule formula.